The concepts of buffer capacities and buffer ranges are very similar, and they're going to be related to the amount of acid and base that you can add to a buffer system before the pH starts to change appreciably, so significantly. The buffer capacity is going to depend on the amount of conjugate acid and conjugate base that are making up your buffer. And we can look at this in terms of a buffer made from acetic acid and sodium acetate. The two examples that are shown, 0.0001 molar acetic acid and acetate ion, or 1 molar acetic acid and acetate ion, are buffers that have exactly the same pH. They're buffers that have equal amounts of the conjugate acid and the conjugate base, so the pH is simply equal to the pKa. And the difference between these two buffers is that the example on the left, with the very, very small concentrations of acid and base, can only absorb a tiny amount of added acid or base before the buffer is entirely used up. That is, you use up all of the acetic acid, or you use up all the sodium acetate. And once you've used up one of the components, you no longer have a buffer, and the pH is no longer going to be held stable. It'll change rapidly. The example on the right is going to be able to absorb much greater amounts of acid and base before that conjugate base to conjugate acid ratio is distorted significantly. A buffer's pH range represents the range of pH values where the buffer can work effectively. And typically, the practical rule of thumb is that buffers have a usable range within plus or minus 1 pH units of the pKa. And this rule of thumb is because, in practical terms, once your acid concentration differs from your conjugate base concentration by more than a factor of about 10, even small additions of acid and base are going to change the pH pretty significantly. And because the concentration terms in the Henderson-Hasselbalch equation are related by a log, a difference of a factor of 10 corresponds to a log of 1, so plus or minus 1. And what this means is that when you're making a buffer, ideally you're going to choose equal amounts of the conjugate acid and the conjugate base, so that that log of base over acid term goes to 0, and the pH is going to be equal to the pKa.